Hey, Etans, welcome to exercise 17.5, where we take a look at polynomial values. Well, firstly, let's begin by asking what are polynomial values, and let's consider a polynomial of x equals x cubed take away 5x squared plus x plus 1. If we were to say, well, the value of the polynomial when x equals to 3, we can replace the polynomial of x with the polynomial or with a 3, and then it will say polynomial of 3. And then we substitute the number 3 into all the x's in the equation. And once we do that, we use BidMaths to find the answer. And essentially, that just tells us what the value is when x is 3. Now, let's take a look at some examples. You're going to get some in different complexities. And let's go with example 1a first. So if polynomial of x equals 2x cubed plus x squared take away 3x take away 4, if p1 or x were to equal to 1 in example 1a, the first step is just to substitute all the values in where the x's are, and then we solve it using BidMaths. For example, polynomial of 1 equals 2 times 1 cubed plus 1 squared. It's good to put brackets around just so we know we're substituting. Take away 3 times 1, take 4. Okay, so once we've substituted our 1 in, we simply go and solve the equation. And we know 1 cubed is 1, so 2 times 1 gives us 2. Well, 1 squared is 1. Negative 3 times 1 gets us negative 3. And then we take away 4. So what is 2 plus 1? Well, 2 plus 1 is 3. May as well write it here. And then negative 3 take away negative 4 gets us negative 7. So 3 takes 7. The answer will be negative 4. All right. Let's zoom in a bit further so we can pack this all into the one column. Let's take a look at what happens in example 1b when p equals negative 2. So therefore, when p is negative 2, we'll have 2 brackets negative 2 cubed plus negative 2 squared. Take away 3 neg 2, take away 4. It's a little bit clustered, isn't it? Let's try and do that again. Should fit. No, let me just pause this and all right, and after some rigorous formatting, we are back. So let's continue. If p were to equal negative 2, okay, this would mean we would have 2 times negative 2 cubed plus negative 2 squared. Take away 3 times negative 2, take 4. All right, so let's see. 2 times negative 2 cubed will get us essentially 2 times negative 8, and that'll get us negative 16. plus, well, negative 2 squared is positive 4. Two negatives times together gets us a positive. Remember, in the calculator for squared and cubed, make sure you put brackets around them so your calculators know to include the negative within the brackets and not beyond. Otherwise, it might be interpreted as negative brackets 2 times 2, close brackets, which means the calculator spits out a negative 4. Okay, so that's a common error people often make. Here we've got negative, let's do that, negative 3 times negative 2. This will get us positive 6. And then we've got a negative 4 to finish off the equation. So negative 16 plus 4 gets us negative 12. Positive 6 take 4 gets us positive 2. So negative 12 plus 2. This will get us negative 10. Alrighty, next one. So if P were to equal A, so polynomial of A, all this means is we replace the x's with A. So we would have 2a cubed plus a squared, take 3a, take 4. Yeah, we can't really simplify that down any further. That's just how it's going to be. For D, if we have P polynomial of 2b, this would look like P 2b, therefore, equals 2 brackets 2b cubed, close brackets, plus 2b squared. Let me just fix up the brackets. Take 3 brackets 2b, take away 4. Now, because this time round, we've actually got a number inside the brackets, we have to simplify it down to the most simplest form. Okay, so we know 2b cubed will be 8, well, 2 times 8b cubed, because 2 cubed is 8, b cubed is b cubed. Okay, so 2 times 8 cubed, 8b cubed, sorry, is 16b cubed. Over here, 2 times 2 gets us 4. We've got a 4b squared. Third term here, we've got to expand out. So negative 3 times positive 2 gets us negative 6. All right, then we've got the b to consider again, and then we've got negative 4. All right, we stop at this line because we no longer have any like terms to simplify down any further. And that's as simple as the form gets for example D. All right, the last one, x plus 1. Feel like this could be a long one, so let's just make sure we can see the formula. So therefore, P x plus 1 is going to equal 2 times x plus 1 cubed. Plus x plus 1 squared. Take away 3 brackets x plus 1, take 4. Alrighty. Zoom back in. See how much, oh, don't have a lot of space. Let's zoom in very close. Okay. So triple bracket expansion. So we've got 2, essentially x plus 1, x plus 1, x plus 1. Let's deal with this first before we look at the others. So this essentially is 2 times, so x times x, x squared, x times positive 1, that's an x, 1 times x, that's another x, plus 1, okay, and then you go to x plus 1. So this will be 2 square brackets, x squared plus 2x plus 1, and you got x plus 1 in the other set of brackets. So what's this? This will be 2 times, or x squared times x gets us x cubed. X squared times positive 1 gets us positive x squared. 2x times x gets us positive 2x squared. 2x times 1 gets us positive 2x. Positive 1 times x gets us positive x. And then 1 times 1 gets us 1. Then we got to double everything inside. And this will equal 2x cubed plus 2x squared plus 4x squared plus 4x plus 2x plus 2. Collect the like terms now, and you're left with 2x cubed plus 6x squared plus 6x plus 2. All right, so that's one portion of the equation. Let's take a look at the next one. So this one here, we've got, well, x plus 1 as a perfect square. So we know this will get us x squared plus 2x plus 1. Well, actually, let's write the steps out since we've written the full steps for the first term. So this is plus x plus 1 times x plus 1. This will be, well, x squared plus x plus 1. So this is going to give us x squared plus 2x plus 1. Over here we have negative 3x plus 3. So all these have different like complexities, and then you've just got negative 4 by itself. So what's important is we got to get out a highlighter just to make sure we know what we're looking at. So the answer for this first term is down all the way here. The answer for the second term is all the way here. The answer for the third term is here. And lastly, the answer, well, 4 to negative 4 is there. All right, so what we want to do is we want to combine everything into 1. So it's nice and easy to read. And so this is sort of a situation where you've got, what did I do? Uh-oh. Redo. Sort of a situation where we want to make sure we combine everything into 1. Okay, so if we just take the highlighted content, we have 2x cubed plus 6x squared plus 6x plus 2. I've written it too big. Sorry for the clunkiness of this video. So we've got 2x cubed plus 6x squared plus 6x plus 2 plus x squared plus 2x plus 1. Take 3x plus 3, take 4. Okay, so collect the like terms. There's only one set of x to the power of 3s. We've got 6x squared, positive x squared. So that gets us positive 7x squared. And then we've got positive 6x, positive 2x, negative 3x. And so 6x plus 2x gets us 8x. Take away 3x is 5x. Then lastly, we've got positive 2, positive 1, positive 3, negative 4. So 2 plus 1 is 3. 3 plus 3 gets us 6. Take away 4 gets us 2. And this here will be our final answer. All right, so that took a lot more steps than I anticipated. But that's all of exercise 17.5. So let me know if you have any issues. Thanks, everyone.